Well, hello there, McKenna, and I'm also going to send this to Jillian, and of course I guess we could share it with anyone else that had interest in seeing it. I'm going to do just a quick review of some of the fundamental examples of things we covered this week, and McKenna especially, I think it'll help you get through the number of assignments I handed to your mom today. And Jillian, you spent so much time this week on student council. I know that academics took a silver medal to that, and we appreciate it so much. And so if this can help you, maybe that'll get you through the weekend as well in getting caught up. So I want to start with some basic things, and I want to remind you of what means what. Throughout this thing, I'm going to use N, as in Nancy, the letter N, as commonly and as normally and as equal as to any random number. So if what I'm saying is not sticking to you and you want to put a number on it, let's just say then, for this exercise we're doing here, let's just say N is 8, if that makes you happy. I don't care. And everything I'm going to say about N, you can simply replace it with 8 or any number. That's what N is, a variable number, and it'll all still be true. So don't let the letter get in the way. It's just another number. Starting with this, just a reminder that different assignments come from different books and places, so you may see the same thing written several ways, such as a multiplication. So for example, if you started with 7n, that is the same thing as saying 7 times n, times as in multiplication. And that is the same thing as saying bracket 7 bracket n. And that is the same thing as saying 7 bracket n. And that is the same thing as saying 7, and if you see a dot, on many of your assignments you'll see a dot. It's not a speck. That's a multiplication in accepted mathematics. And of course, using the other distribution principles, we can, because it's multiplication, all these other things are true as well. So continuing, all these are equal, and they are also equal to n7. It's also equal to n times 7, equal to bracket n bracket 7, equal to bracket n 7, or as we did with this one, n dot or times 7. Okay? So all of those expressions mean the same thing. Another basic of the distributive property, the types of word questions you're going to get, it'll really help you get through, because the first thing you want to identify in a word problem is what action, what's the function of this? You know, I have 7 balls and I lend someone 4, how many are left? That's going to be a subtraction question. And oftentimes you'll say, you know, whoever has something of something. When you hear or see the word of in mathematics, and I know Madame has said this, but it can't be said enough. It can really propel you into getting to the right answer and getting there more quickly, because you're not hovering about what's the main function of this expression. Every time you see the word of, I'm going to have 7 of those Canadian flags, please, for my Cub Scouts. That means I want 7 times the one Canadian flag. 7 flags. 7 of those flags. 7 times that flag. Always, and for the rest of your life, it'll never change. I would like 7 pieces of that pizza. That means take that slice of pizza and get 6 more, because I want 7. Another way, of course, is this. I'm going to skip this for the moment. 7n minus n. No, let me go back a bit, sorry. Let me go back a bit. If you replace the word of with a multiplication sign, you will always be right, and you'll get to the answer correctly and more expeditiously. Okay? These are 2 things that I wanted to say after that. I want to talk about this. I'm going to skip that. I want to talk about this. Many kids in our class have had trouble with an expression like this. And they've left it because they think that's as far as it could be simplified, or they come up with, my phone's going to ring in my pocket, but I'm just going to talk through this. I'm going to give you one long video. You can fast forward things like this. And so when you see 7n minus n, well, what is 7n? 7n is n plus n plus n plus n plus n plus n plus n. That's 7 n's with 6 plus signs. And if you saw that, you would simplify it by saying 7n. So 7n is all these n's added together, and the rest of this equation here is minus n. So obviously, your answer, because these are of the same family, you got 7n and you've got really 1n. n or 1n is the same thing, because remember 1n means 1 times n, and there's 7n. Okay? So therefore, of course, you wind up with 6n. Now, of course, if this was an A or a B, well then of course that is as far as you can go, because B and N are not of the same family. They're not necessarily the same value, so you can't make any assumptions until you might find out more about their value later on. Okay? So just want to clear that up, because kids have obviously struggled with that because I've seen it on the homework. Okay? Another thing in this vein, 5 carrots, excuse my lousy art, 5 carrots minus 2 carrots. I've seen people leave that alone. They didn't simplify it any further. And then there's added 4 grapes at the end. But you can simplify that, because 5 carrots are 1, 2, 3, 4, 5 carrots. 1 plus 1 plus 1 plus 1 plus 1 equals 5 carrots. And minus 2 carrots, well, here's 2 carrots. A carrot plus a carrot. So 2 times a carrot, or 2 times n, or 5 times n. So the simplification, of course, is you've got 5 carrots, same family here as here, minus 2 carrots. Well, you're finishing with 3 carrots plus still 4 grapes. Can't do anything further, because grapes and carrot are not of the same family. Okay? One other thing, and then we'll get to the actual questions you're going to be dealing with, but these are really key fundamentals you've got to remember. When you see an expression like this, a fraction in front of a number, or a whole big expression, or just a letter n, doesn't matter. This n could be 8, this n could be n squared plus 3n minus 4n plus 5k minus 7t plus b. It doesn't matter. Whatever this is, if it's being multiplied by a fraction, I'll ask you, what does that mean? Does that mean A, 2 over 5n? Does it mean B, 2n over 5? So the n here went with the denominator, the n here went into the numerator, that's the thing on top. Or is it 2n over 5n? And of course the answer, you got to know, it's going to be the answer that matches my code. It's not 2n over 5n, because n over n just nullifies itself and you wind up with 2 over 5. Well, 2 over 5 times n is not necessarily 2 over 5. Of course, unless n was 1. But n could be anything, so that's wrong. And you don't put it down with a denominator. You put it here, just like the color of Coach's jacket, 2n over 5. What you're multiplying the fraction against all goes times what's in the numerator position. Okay? So I want to identify those, because they were key things that I've seen go wrong over my week here enjoying your class. So let's continue now into the distributive property per se. And let me just give you a few examples, and I think that'll help you if you're stuck. I also very much encourage you. Madame Valcke gave the class, McKenna, I know for sure was the first thing I put in your package today for your Mom Kelly, is a 4-page document called the Distributive Property, and it really breaks it down in a very simple and understandable form. So I really recommend you look through that. and then you don't have to listen to me blabber. So I'm going to do a few examples here, and each one's going to get a little bit tougher, but I think if we go through 4 of them, you'll be ready to tackle any of the equations or expressions that you need to simplify in the homework that you have not finished yet. So let's start with this one. Another simple thing you've got to remember. Let's say you've got minus 13 plus n. We'll go back to n. Okay? N means any number. Okay? Could be 8, could be 12, it could be 8 billion. Doesn't matter. It's just a variable number. Don't get messed up on that. When you see this, I've seen people in our class get pretty far down the hard stuff and then drop the ball when they get to something relatively easy like this because they get tricked with that minus sign and how to distribute it. The way you should think of it in your mind, when you see a minus sign, just put a 1 here. It'll just remind you to do what you always do when you distribute. In other words, distribute it first to this element and then distribute it to that element using this same operational sign. So in other words, equals minus 1, I'll put it in brackets, times 13 plus minus 1 times n. You've got this. You've got this. Can of corn. This equals minus 13, oops, minus 13 minus 1n, and of course, you can use just n. 1n and n are both the same thing. And excuse me here, this little dot is not a minus sign. This is a minus sign. Okay? So there's your simplification. So a lot of times when you see a minus in front of a bracket, if you're unsure about anything, just put a number 1 there and you'll remember exactly what to do. Okay? I know this video is getting long, so I'm sorry about that. I don't want to make it any longer, but wow, look what Eddie gave to me. I don't know if I can get this darn thing open. Oh, look at this. Oh, man. It's a red Valentine's heart. Wasn't that sweet of Eddie? Man. Oh, my God. It's just amazing. Aren't you glad I saved this video? Wow. Okay, I guess we'll get back to work. Okay, back to the next one. We're going to get a little bit harder with each equation. The next one we're going to use the distributive property on is 3n plus 4. It can't get simpler. Distribute it here, drop the same operational sign, and then distribute it here. 3n plus 4 equals 3 times n plus, because that's the same sign, 3 times 4 equals 3n plus 12. Okay, and that's as far as you can go because, yes, these are both numbers, but the n times the 3 makes the n a different family. So you can't say, oh, that equals 15n, or that equals 15. No, you can't add. It's like adding apples and oranges. Okay? Make it a little more complicated. Let's put the n on the outside of the bracket. So we got 8n times 7, and let's put an n in the middle of this thing too, just for the heck of it. Actually, let's not. We'll do that in a sec. Let's put a b here and just see what happens. Again, b is any number you like. B is just a variable number, and whatever number you choose to put in there, it's going to work. It'll prove itself every time. So factoring this, again, we distribute 8 against that, 8n against that, and then after dropping the same operational sign, we go against that. So what do we have? Bracket equals 8n times 7 plus 8n times b. Okay. Where do we go from here? This is all multiplication, so it's very reasonable to put 56n, that's 7 times 8. Don't know what n is, so we just keep n as a multiplier. We use the plus again, and we've got 8n times b. Nothing common, so we simply write this 8nb. And that means we multiply 8 times n times b. Okay, and just to go back what I had initially put, let's say this was n, which is the same thing that's outside the bracket. Let's see what happens with that. So we simplify the exact same way. Bracket 8n times 7 plus 8n. We're going to distribute it. Sorry. Bracket n. So what do we got? As we knew from the previous one, 56n. By the way, the reason I know that's 56 is because 1,000 years ago, when I was a kid, we worked with flashcards. We had to learn the 12 times 12 table automatically, like blinking your eyes. Our teacher grilled us for it. And I can't tell you over my life how much time has that saved. Shopping, going to restaurants, finishing off university type equations. Doesn't matter what it is. Having that 12 times 12 table, parents of these two girls or anyone watching, if you can get a set of flashcards online, create them yourself, and just keep flipping them until they know automatically 8 times 7, 56. 9 times 6, 54. 9 times 9, 81. 8 times 11, 88. You know, it's just automatic like a calculator in my head because I got drilled with it so many times. I wish kids didn't use their calculators that much. 56n plus 8n times n. So we could write that 8 and n, because remember when it was b we went 8nb, but you could simplify that. N times itself, of course, is n squared. And if you want to finish it off perfectly, exponentially they should go in order. So I would put my final answer as 8n squared plus 56n. And if I had a number without an n, then I put it here. If I had a number 8 cubed or 8 to the 4th or a higher exponential power, then I put that over here, you know, 17n to the 4th. Most of the time, people will put the highest exponent first. It just kind of reads better. It makes better sense later if you have to use it in a problem. Okay? So, we're getting to the two final ones. They're both a little tougher than that one. And they involve minus signs. So let's go back to a basic distribution question. Let's get 6 times n, oops, not plus, that's the whole point of this. And minus 4, just to cover all the bases here. Okay? Equals, I'm just going to write 6n. You know, before I was writing bracket 6, bracket n, but if you want to just go right to 6n, that's fine. I think you know that already. Bring the minus sign down, and then forget about it. You brought that down as you should have, and 6 times 4 is, of course, 24. Now before I had written that as, you know, bracket 6 times bracket minus 4, you know. But you guys know 6 times 4 is 24. So there's the end of your problem right there. And you can't simplify any more than that. Okay? And then the final one I'd like to do is just a couple of minus signs, because that's again what, in looking at what people have handed in, these are the places that I've seen the most common errors. Let's use, for example, minus 9 times n minus 2. Okay? And again, these are the places where I've seen careless mistakes made. So you just kind of think it through. you just have to apply the same principle, which is this. Distribute the 9 here, drop the sign. You distribute the 9 here, okay? Minus 9 times n. Drop the minus sign. Or actually, you can do 2 things here. You can bring the minus sign down, as we often talk about, and then go minus 9, because that's still out here, this minus sign, times 2. The 2's minus sign we put here, and remember, a minus bracket is the same as putting minus 1, just so we're not going places you don't understand. But the 1 is redundant. Okay? And our final answer, minus 9n, minus times a minus, or a minus 1 if you like, times a minus, that's a positive 9. The way I think of it all the time, whenever I would see 2 minus signs multiplying each other, I'd always take one, flip it 90 degrees and stick it on the other one. So it looks like this. It says minus 1 times minus 9. I would take this out of my head, I would take that and just put it vertically, and I'd change that into a plus. It's the same thing. Minus a minus is a plus. Minus times a minus is a plus. That's the way I used to think in my mind. You don't have to do that. You just have to know a minus times a minus, and you don't need the 1. The 1 is redundant. So we're going to have a positive result, so it's going to be 9 times 2 plus 18. It's plus because we had a minus times a minus. We had a minus up here, we wound up times it against that minus 2. So the minuses will nullify themselves, and they wind up with a positive number. Okay? Those are the examples I wanted to paint for you. Each one gets a tiny bit more complex, but the principle's always the same, and you just take your time, and especially when it gets into those minus signs, because that's where I see the most errors in your class. Sorry this took so long, but I hope it's helpful. I hope you don't spend too much time watching me this weekend, because you got 3 great days ahead of you, and I look forward to seeing you on Tuesday when you come back.